But I think if there are people on the call that never seen another data set, I hope in the next hour and a half you may have an understanding of what is ADAM. Today's topic, that is ADAM. So what is ADAM? Essentially, ADAM is one of the CDISC models. Okay, here I'm going to report what are the official definitions from the CDISC implementation guidance. There are also the definition that we usually cover in the standard ADAM training. So the CDISC ADAM training, just for your information, it's one day and done. So what we're trying to do today is come out quite challenging. And so essentially, the ADAM it's one of the CDISC model, one of the models that CDISC has developed, and it's specifically for giving some guidance and standard guidance on how to create analysis data sets. Essentially, in these 3 bullet points, what CDISC wants to say is basically with this, with ADAM, as I will try also to explain in the next hour, it's not just about how to name a data set. It's not just about naming variables. There is more, and actually the more it's actually what is more important in ADAM is that your data set in the end, they are understandable. They contain everything needed for the analysis, and also everything that would be needed by the reviewer to understand what you have done. When I say reviewer, it could be the regulatory reviewer, but it can be also statistician or the sponsor. And as such, it should, it might combine observed observation, so record coming from source data, or the SDTM, and derived observation. And in the end, the ADAM data set, your analysis data set, if they are done according to the ADAM principle, they will help to understand basically, it's all about traceability. They will help to understand the data lineage from collection to analysis to results. This will be more clear, hopefully, in the next slide. Actually, the last bullet points, as I said here, so 1, 2, 3 is from the ADAM guidance. Bullet point 4 is from me. So in the end, it's more flexible than SDTM. As we'll explain later on, you're not obliged to use all the variables that the standard includes. So somehow this is a pro. There's no that many description like in SDTM. You don't have to remember, okay, if I use this variable, I should use this variable. If I use this data set, I will need to use this data set. So we are more flexible in ADAM. ADAM is more, it's essentially it's analysis driven, which give you, which makes the ADAM actually less standardizable, because the amount of analysis you can do is so huge that you cannot predict all the analysis data sets that you may want to standardize. And that could be actually the cons, because it's flexible. People may think they can do whatever they want. They can do whatever they want, and actually they can be they can use their fantasy, let's say, to build some analysis data set, forgetting what are in the end the principles. So ADAM has some principles that has to be respected. But people might think that because it's so flexible, they can forget about those principles. In the submission context, so where is it ADAM? So this is a chart that we usually often use in the CDISC training, and this is summarizing all the available standards at CDISC. Some of the key what are called the foundational standards at CDISC, from planning to data collection to data tabulation and to data analysis. As you can see, those where FDA is mentioned are the standards that are currently required by the FDA and PMDA as well when you submit data to the authorities. And Adam is one of the standards. Adam is the standard to be used when you submit analysis dataset. What is about the Adam guidance? Adam guidance, it's actually one first clarification wants to make, and this is the same for other standards in CDISC, is the distinction between version of the standard. So as of today, we have Adam version 2.1 from the implementation guidance. The implementation guidance, in few words, it's a document which provides description on how the standard has to be implemented. So it contains more examples. So you may, and as of today, we are at the version of the implementation guidance is the 1.1. The version of the guidance 1.1, the implementation guidance 1.1 is using Adam standard 2.1, the model 2.1. So, for example, the Adam standard 2.1 was released, I think, sometime around 2009, together with the first version of the implementation guidance. And the implementation guidance 1.1 was released, I think, a few years later. But the new implementation guidance, so the 1.1, did not require any change in the standard. Okay, so the standard remained the same. It's just the implementation guidance that changed because it provided more details. This is because very often you release a standard, you think it's okay, people start to use and people start to question, and therefore the Adam team at CDISC realized that there was something missing, something was not well explained in the guidance. And that's why there is this kind of disalignment. And this is the same for STTM. So in the end, Adam, it's composed by a number of documents that are all listed here. So there is a document describing the standard, a document, the implementation guidance, and then there are other documents that have been developed. Like, for example, there is where is it? The third document listed here. It's now become a bit old. So CDISC is planning to update this. It contains good example on how to implement Adam with the standard analysis. Like there are a lot of examples on repeated analysis, like ANOVA, or I think also some examples for logistics implementation. So for each of these type of analysis, they make an example of how Adam should be built to support this specific analysis. Okay? So I'm not going through all these documents, but all these documents together, they make Adam. And then you can see, not sure how much of you are familiar with the therapeutic area user guidance. This is another set of guidance that CDISC released that focus more on the implementation of standard in a specific indication. And in there, you can also find some other examples related to Adam. So you can see here there are a number of implementation guidance, maybe difficult to read, but you can see that most of the guidance, they cover topics around the terminology in STTM, but recently some of the guidance, they also started to provide example of the use of Adam on that specific indication. One example is the oncology therapeutic user guidance. They provide a lot of example on time to event analysis, because time to event analysis is one of the main way of analyzing oncology endpoints, oncology efficacy endpoints. So in those guidance, you can see, if you're working on a study on any of that specific guidance, you can, on any of that specific area, indication, you may find some example that you may use in your trial. This is just to show what's next in the Adam development. So they will release soon a new version of the guidance, which will be called version 1.2. And I don't think it's planned to update the model. So the model will stay as 2.1. And this is another document. So one of the current issue of all standard is that they are all developed having in mind one study. So most of, if not all the standard, and that includes Adam, they are not yet ready to support, for example, pooling. So when you pull together a study from the same indication for a submission purpose. So there are some instances where the standard doesn't fit very well with the requirement of pooling. Okay, just to give some to make to introduce Adam. It's a way of introducing Adam is to say explain the difference from SDTM, and this is actually by explaining this difference, people hopefully will understand why we need another set of data sets, because it is often unclear for people why we need SDTM and then also Adam. Well, the example is the reason is pretty clear, should be pretty clear from this table. Again, without entering into details, I just want to focus on one main reason. The main reason is that with SDTM, we can only store collected data. And with the collected data, we can, this collected data, they are, one may do analysis directly from SDTM, but it's not always the case. So there are many things that are not collected that are actually needed by the analysis. One example is the study population. So these are variables that you don't collect. Or deriving a complex endpoint like survival analysis. This is not, of course, collected in the CRF. You collect data to build these endpoints, but you don't collect overall survival. Also, in the data, you may have missing data. These are unfortunately still happening. And when it's time to analyze the data, if you have a missing observation, a missing time points, or a missing value for the variables, you need to make you need to take some decision, and you need to decide how to handle this missing data. So that's something again you don't do in SDTM, you do in Adam. Okay. And then there are other little differences related to the type of variables. So SDTM is primarily most of the SDTM variables are of character nature, while in Adam, depending on the analysis you have to make, you may have numeric, but also numeric and characters variables. And just to give you an example, I mentioned before, so you may have your data stored in SDTM, collected and then stored in SDTM, and you, for whatever analysis, you have to use one of the variables you collected. The example is the relationship, the drug relationship for adverse events. You may have an adverse event here, the sixth row, where the relationship was not collected. And what you do in Adam is, first of all, you need of course a statistical analysis plan to tell you, okay, how do we make an interpretation of this missing value? Do we assume that if it's not related, it's related? So we go with the worst scenario. That is usually what we do. So that has to be stated in the statistical analysis plan, of course. So once you have the rule in place in the SAP, so the way of handling such a situation in Adam is actually not to impute the missing information in the original variable. So ARL is coming from SDTM. So you will probably have in your ADI dataset this variable called ARL. But if you need to make an assumption of this missing value, you will need another variable. And very likely it will be called RelGR1, meaning meaning that we are making a grouping of relationship, and in there you make the imputation. You can see also here we made also a grouping, meaning that in the CRF the relationship was collected through different levels of severity of the relationship, while in the analysis we need only to say whether the adverse event was related or not. Okay, so here we use this variable to make an imputation, but also to make some grouping of relationship. Now, okay, let's start to see what are the basic rules for Adam implementation. It's very likely that you will need to skip the lunch because it's taking more than expected. I'm joking. Okay, so the source of Adam. Adam, to be compliant, has to be derived from SDTM. If you are creating other data set from non-SDTM, this could be not considered Adam compliant. However, you can, if you want, use Adam principle to create an analysis data set, even if when the source is not SCTM but raw data. So another data set can be derived from an SCTM, from multiple SCTM, from another Adam data set, from many other Adam data set, or it can be derived from a combination of SCTM and Adam data set. This probably will be more clear in the next slide. So as I said, it should be derived from SCTM, but the only exception is when, for example, for SMQ, what stands for SMQ, standard medical query. So it's another way allowed by Metadata to classify, to group together similar adverse events. Very often we receive this classification at posteriori, so when the database is locked. So usually coding specialists provide this additional way of mapping adverse events. You receive usually an Excel file. So this Excel file is not doesn't contain subject-related data, but it contains a definition for grouping adverse events. So usually you import this data set, this Excel file into this data set, into a SAS data set, and you use this data set to create your adverse events analysis data set to group adverse events by this additional way of classifying adverse events. So this data set will be not SCTM, will be not Adam, it will be something else. But it can be used when you create Adam. And if you have such information, this data set should be part of the submission if you submit this data set to the FDA. Okay, again, more rules. So there should be at least, so if you create an analysis data set according to Adam, there should be at least one data set called ADSL. And this is a data set containing subject level analysis, subject level information. So it's basically one record per subject containing some key subject characteristics. And there is not a good or bad number, good or wrong number of analysis data sets. So the number of data sets, it depends on the, it's again analysis driven, depends on the analysis expected. And the convention is to name the analysis data set starting with AD. That stands for analysis data set. And if in the package you have both, if you're in the package of your data set, you also have non-Adam analysis data set, the rule is to name the data set starting with AX and not AD. This this is to make clear in the submission that this data set is not it's an analysis data set, but is not Adam compliant. And then of course you are, as I said, it's very flexible, Adam, but whenever there is a standard variable in the guidance, you have to use that variable, okay? And there are also some naming convention that should be used when you create your own variable. So compared to SCTM, Adam is very flexible in this. So if none of the standard variables fit with with what you are deriving, you can add variables to your Adam, while instead in SCTM you have to make something that's a bit more complicated. So you cannot store a non-standard variable in a standard SCTM data set, but you need to use something else called supplemental qualifier, which is very odd, it's still there. Okay. And there are other rules. So as I said, Adam, when an Adam data set is derived from SCTM, very often you copy variables from SCTM, and from this variable you start deriving other variables. So when a variable is copied from SCTM, this variable should be not changed, meaning that you cannot change the value, you cannot change the name. So the principle that is same meaning, same values. Okay. There is just a few exceptions, like the variable DS, the code in SCTM. depending on other variables, yes, the code in SCTM can contain several different information, can contain end of study reason, can contain end of treatment reason, can contain whether the patient was signed informed consent. So if you keep this name in Adam, the variable alone won't be sufficient to describe its content. So in this case, that's the only exception where you can use a different name, and actually in Adam, for example, for end of study, there is a specific variable. Okay. And then, I mean, there are sponsors that maintain a list of sponsor standard Adam variables. We don't do that because we work with so many sponsors, but at least try to be consistent within your project. If you have a submission with several studies, try to be consistent across studies. And of course, because unfortunately, as of today, we are still using, when we submit data to the FDA, we are still using a format that it's about 30 years old. And this format, which is the SAS transport file, has some limitation. And all standard at CDISC, and the same as for Adam, of course, it's added to some of the limitation that this SAXSPT is giving, like the name of the variable should be 8 characters maximum, the label should be 40 characters, and so on, so on. I'm not going through all these bullet points. There are just a few exceptions, like in SCTM, the param CD, which we will quickly see later on, could be not more than 8 characters, and the param variables could be 200 characters. That is the maximum allowed length for character variables in the SAXSPT. But the recommendation is to use 40 characters maximum. And there is a reason for this, because very often this data set that I introduced in a while that use these two variables, it's an extremely normalized data set, and which is very verticalized data set. And for when you need to analyze, when you need to use this data set for analysis purpose, you may need to transpose the data set. And what's in param CD may become the name of the variable, and what's in param may become the label of the variables. And in SAS, the label of the variable is 40 characters long. So if you have a param with more than 40 characters long, your label will be truncated. Okay, so as I said before, in Adam we have a mixture of numeric and characters variables. So character variable, whenever possible, is a preference, because the character variables, especially for categorical variables, they are ready for the tables, so they already contain the value that you want to present. Numeric variables, when of course a statistical model requires a numeric value, or when you use character variables, but you want to make a different sorting in your output, because the character variables sorting may be not the optimal one for the table, then you may have also the numeric counterpart, so numeric equivalent variables. So whenever you do that, that's the sample. So you have a sex, race, for example, that are character variables. They contain the code of the sex of the race, but maybe the way the alphabetic order of race is not the way the order you want to use in the output, and therefore you can create a variable called race n, where you actually assign a number to each race. The number will be the order that you want to see in the output. Just a reminder, the Adam dataset, but same SCTM, actually I think it's a limitation of the SAXSPT, doesn't allow for SAS user formats. So whenever you create this dataset, you need to remember to remove any SAS user format assignment to your variables. And if a variable is a SAS numeric date, make sure instead you have applied a SAS format. Otherwise, the reviewer, okay, may assign himself the format, but that won't be nice. And whenever, as I said before, you have the freedom to create new variables when standard variables are not enough. But the recommendation is to use some naming rules that are in this slide summarized. And you have something called a fragment for some standard meaning, like if you have to create a variable containing a change, the variable should have a suffix chg, and so on and so on. And in the right part of the slide, you can see, depending on what kind of concept you're building, you can compose the different elements that are mentioned in the format part to build the name of the variable. For example, SBP01BL is the systolic blood pressure at baseline, and probably this is an example coming from a study that has a crossover, where you have several baselines, or you have several periods, and in that case, the analysis was requiring the baseline of the systolic blood pressure at each period, and therefore you have the period component. Instead, if you see the weight SC, it's the weight at screening. So the screening is probably just one. In that case, you don't need the period fragment. I'll let yourself see the other example. Okay, so also for Adam, so you need to use if a variable is standard, use the standard label. There is for variables that have, if you open the implementation guidance, there are some variables that have that are named using some special character like Y, W, XX, and so on and so on. This means that you can create several variables with the same name, and XX or W, Y, and Z can be have to be replaced by a number. Like for example, here for the analysis flag, you may have in your dataset several analysis flags, so you assign a number to each of the analysis flags. And the same in the label, so you have the same in the label, so you have to replace here ZZ with 01. With the version 1.1, specifically for analysis flag, you can add additional text. You can see here to make the label more meaningful, because what is about analysis flag 01? It doesn't say anything. You need to probably open the FineXML, open reviewer guide to see what is flagged in this variable. But you have now the option to add additional text. Okay. Now, add-on classes. So for those familiar with SCTM, we also have, in SCTM, we have classes of dataset. And depending on which classes an information and dataset belong to, you have to follow certain rules, right? And the same in Adam. In Adam, it's a little bit more simple. We have, as of today, 3 classes. One is ADSL, which I mentioned before. And essentially one record per subject, where you have demographic information, information about the treatment or the arm assigned to the patient, period, if your analysis requires periods, key baseline characteristics like weight at baseline, height at baseline, and study population indicators like safety flag, or this something, I think it's a full analysis flag. So this is one record per subject, as you can see here. Okay, it's very straightforward actually. Actually, it depends on the study design. It is not actually very straightforward, but it's a very important data set. And that's the data set you start building first, because it will be used by other data sets. The other structure, it's very, let's say, it's a very generalized structure that can be used in several situations, and it's usually one or more record per subject, per analysis parameter, per analysis time point, if your analysis has the analysis time point. Otherwise, the time point variables are not needed. This is an example of a laboratory Adam dataset. You can see Okay, such identifier, some variables coming from ADSL, the population indicator factors. Then some variable identifying the time point, the visit, and eventually also the exact date of the visit. Some variable identifying the topic of the analysis, and usually you have two variables, one short version called param_cd and one longer version describing more in detail what is about ALT. And for those familiar with SCTM, you can see that you may think this is equivalent to the test variable, but it's actually more than that, because actually in param you should add all the description parts that make the definition of the param. So in this case, for labs, we also have the unit. While instead in SCTM you have a separate variables. And you don't need to concatenate all the information you have, for example, from SCTM LB. So you only concatenate the information in a few words. This param should match this text should match the text. Where is my mouse? The text that will be used in the output. Okay. So in the output, for example, you have an analysis of your lab data set by specimen use, right? Urine, the you had also the specimen part, but if you don't have to make an analysis by specimen, in this specific example, the name and the unit is sufficient. And then you have a number of variables that contain actually the results. Very likely there will be AVAL. So in this case means ALT were 43 UL. And then all these other variables that are here in yellow, you create these variables if you have, for example, a change from baseline analysis for labs in your study. If you don't plan any change from baseline analysis, you are not required, for example, to create this variable. But most people create this variable anyway. Okay. As I said, the BDS can be used for several different situations. So this is pretty straightforward. So most of the records are coming directly from SCTM, and then you change a bit the param to be more meaningful. You add some derived variables that are very standard. So So eval, base, CHE, and so on. They are always the same variable. They always have the same meaning, regardless of the analysis you are doing. There are other situations where actually the records, again, it's a BDS data set. You can still recognize param and param_cd in both examples. But these are purely, let's say, derived data sets, right? The information in this data set are summary information. The first one is summarizing the adverse event experience of each subject. So for example, how many, whether the patient had or not at least a treatment emergent adverse event, what was the maximum grade severity of all the adverse events, and here you have one record for each summary statistics. For each summarization that you will need then to summarize, to count in your tables, okay? And again, you can use the BDS to build analysis data set, other data set to support, for example, survival analysis. And here you need additional variables, because if you are familiar with survival analysis, the time, the endpoint, and survival analysis endpoint is built of two components for the time, which will be again eval, so 11 days, but you need to know whether or not the event occurred. So you need another variable called CNSAR, the stand for sensor. Okay. So depending on the type of the endpoint you are creating using this structure, you may need or not additional variables. Okay, and this one should come after the next one. Okay, as I said before, if you're not following any of the Adam classes, but you are still following the Adam principle, you can call a data set Adam other. Okay, so in theory there is also a fourth class called other. Okay, Okay, this slide should have come before. So the third structure is called occurrence dataset, which you will not find in the implementation guidance 1.1, but it's in a separate document, because this was introduced after the implementation guidance 1.1. But in the new guidance 1.2, this new structure will be in the same document. And this is a structure that was added specifically initially for adverse events, so a situation where you need to make some count of occurrence. And then the initial proposal for adverse events was generalized, and they built something called occurrence dataset that you can use in any situation where you have to count occurrence. And very often it's these dataset, also dataset that they have also incorporated the medical dictionary hierarchy, like METRA or like WHO drug dictionary. And in short, it's very similar to, if you take the example of adverse event, the analysis dataset using this structure will be basically copying all variables from AE. And then if you also have information from sup-AE, this sup-AE variable will be transposed. And then you will need to add flags, for example, to identify the first adverse events, the patient experience, the first serious adverse events the patient experienced. So all these flags will be used then in the output program to select the record. And then again, you can have like here in the example, you can have a variable coming from SCTM, like AESER. It's a variable containing the seriousness. And then again, if you need to make some imputation because not all adverse events had the seriousness specified in the data, then you can make assumption and impute your seriousness using an analysis variable that will be called AESER. Okay, that's just an example. Then, there are no strict requirements related to variable order in the dataset. So the way the variables appear in the dataset is not mandatory. There are no strict requirements, as opposed to SCTM, where you have to respect a specific order. U sub j d should be the first variable, and then and so on, so on, so on. In Adam, you don't have this restriction, but I can make some recommendation to make, of course, if you have a sparse order of the variables, then the data set will maybe become difficult to read. I can tell you that it was not me making this submission, but in our previous company, because they did a submission, without Adam, but they submitted an analysis data set. The submission was rejected for other reasons, so for efficacy reasons. But I can tell you the FDA provided a lot of comments and complained a lot about the way data set was built. So in a few words, they were, I don't know, age, sex at the beginning, the subject ID in the middle, so it was a very big mess. So the reviewer complained because he was not able to read once opened the data set, he was not able to understand what was in there. So this is just a proposal on the order that the variables, depending on which category they belong to. So this is just the proposal. There are sponsors that they prefer, for example, for the BDS structure to have parameter at the beginning, so you already know by opening data set that line refer to the specific parameters, and then maybe have afterward the population flags, and then all others descriptor variables coming from ADSL at the end. So that's it's really sometimes there are some sponsor preference. That's my preferred ordering. Okay. Okay. So this again, this is to make sure that people do not do create Adam dataset only when needed. So the usual question is how many Adam dataset do I need? Again, the usual answer is it's everything analysis driven. It depends on your statistical analysis plan. It depends on the outputs you have to derive. From the regulatory point of view, you need for sure ADSL, and FDA in its Study Data Technical Conformance Guide. They provide some recommendations. So, for example, they want to see ADSL, and they want to receive ADAM dataset supporting primary and efficacy endpoint. So, in theory, if your analysis is very simple, ADSL may be enough. So, if your primary outcome is subject alive or not at the end of the study, that's just the binary variables that can be stored in ADSL. In reality, it's not so simple, so you have many other data sets to submit. But for sure, you will probably not need another data set for inclusion-exclusion criteria. What's the point? If you have to create a listing, there's no need to create another data set. Other data sets are supposed to support mainly tables and figures, not listing. Okay. And also, if you have to create a table containing medical history, you can also create the output directly from the SDTM dataset. Okay, there's no really need to create another dataset for medical history, unless you have to make some imputation or missing values. Okay, and we said that ADSL should contain all the variables describing key characteristics of the subject. But if you end up with a big data set, okay, there's no clear rule on this, but I would say if you see more than 80 to 100 variables in your ADSL, there is probably something wrong. There is not something wrong, but you may think about creating a separate data set that you may call AD base, which is not a standard name, but you can use this as a possible name, where you can store additional subject characteristics. Okay, so do not try to squeeze all baseline variable into ADSL. And also, analysis dataset name do not need to parallel SDTM. So very likely, if you are creating an analysis dataset for adverse events, very likely its name would be ADIE, and for vital sign would be VS. But if you are creating, again, it's analysis driven. So if you are creating if you have an endpoint that is using adverse events data, but of time to event nature, so if you have to create a time to first adverse event, so you will have for sure something called ADIE to store adverse event information to support the standard adverse event table, and then for the time to event for the time to event endpoint, you may have something called AD-TTEAE. So there is not a unique, let's say, a one-to-one relationship between SDTM and ADAM. So you may have one data set in SDTM from which you create 10 ADAM in ADAM, and the other way around. You may have 10 SDTM data set from which you create one ADAM. Okay, that's somehow already covered this in the previous slide. So there's no need to have another data set for each SDTM data set. Okay. The other question, as I said at the beginning, the ADAM data set will usually contain data coming from SDTM plus derived records. The question here is, do I need to replicate in ADAM all SDTM data, so all SDTM records? As I mentioned at the beginning, the ADAM suggests to collect both observed data and derived data. So if you are creating I don't know, if you have a repeated analysis where you have the same results, the same information collected at different time points, and then you need to summarize this. Let's say you need the average of these time points per subject, or whatever. If you create a data set, another data set, do not store just the record containing the average, but also store the records from which the average was built. Okay, this gives the data set more traceable. We'll see later on what is what's the meaning of traceability. Okay, of course there are situations in which you may end up with big data sets, right? And there you have to probably find compromise, and maybe maybe there you may decide not to store all the records. As you may not know, or you may know, FDA has some limitation in the size of data set. As of today, it's 5 giga. So an individual data set submitted to the FDA can be not bigger than 5 gigabytes. So there are situations where, for example, with labs, you may have a huge data set, but if you store in Adam also all individual records from an SCTM, you may exceed this 5 gigabytes limitation. Okay. So I mentioned before fundamental principle. So if you're able to create an analysis data set, having in mind these 4 fundamental principles, we can consider Adam data set Adam compliant. If you're not able to follow this principle, actually this principle plus the rules we saw before about naming convention and so on, if you're not able to follow these rules, we cannot consider our analysis data set Adam compliant. So if you don't have metadata for the fine XML, the Adam data set could be not considered Adam compliant. Okay, the last bullet point is okay, straightforward. It's just they want CDISC when they mention be usable with common available tools. It means that regardless if you're using Adam or SAS or R or whatever tools, there shouldn't be any. There shouldn't be any rules that fit just with one tool. Okay, in the end, FDA wants fast XPT, so there is some kind of tool dependency. That's okay. That's a different story. And then let's focus on the first 2 fundamental principles that are, for me, the key for understanding Adam. And these are the key for making. These are the key to avoid to make mistakes. So that in applying standard, there's not such a big mistake that will put at risk your submission. Okay, if your drug doesn't work, full stop. But it is important to be when you build your data set, and this is the same for CTM, to make a structure that is clear, it's understandable, and to provide documentation in support of the data set that make what you did fully understandable. Okay, don't have to hide things. Okay, these are all about traceability, and be analysis ready somehow goes together with traceability. So what is about traceability? Okay, you can read the 2 definitions from FDA CDISC, but in the end, as I said before, traceability means transparency. Okay, and in summary, you need to be able, and to explain this, I use one kind of standard slide very often used in the CDISC training. If you start from, if the reviewer opened your package, you will start looking probably at the results. We will open a table. This is a table using, I think, summarizing the overall survival. So it's a time to event endpoint. Okay, is to look at the table. Then one thing the reviewer has to, the reason why there is a reviewer is that because the reviewer has to make sure what you did is appropriate. So you also have to make some checks, and this means that in practice it will reprogram some of your analysis. But to reprogram, you need to understand, to reproduce what you did, you need to understand what you did. Okay, so we'll open this table, and then you will start to look at the table and to understand what you did. You will look probably. Okay, there is something we'll introduce at the end very quickly. It will try to understand how you build this table, which analysis data set, which variable you use, which selection you made. And this is if you submit analysis results metadata, this will be described in the analysis results metadata. Otherwise, it will be described in the reviewer guide. Then, okay, once we understood, okay, for this table you use the Adam dataset code ADTTAE, let me see, and you use the parameter overall survival. Okay, it will open ADTTAE to see, okay, let me see what is it. And then, okay, let me see how this sponsor derive overall survival. So we will open the fine XML. The fine XML, we will look at the specification. It will hopefully, if the sponsor made a good defined XML, the reviewer will be able to understand which data set, which variable, and which specific selection criteria the sponsor has used to derive overall survival. Which, for example, which information were not considered in deriving overall survival, and why, okay? And then, okay, because he wants to reproduce your Adam, because he doesn't trust you, okay? So he thinks you did, you always do, you're a sponsor, you always, by definition, make mistakes. He saw that you use the CTM, so to build this data set, overall survival is basically about time to death, right? So the death information is in the end data set in a CTM, okay? There are two variables, one for the date and one saying whether or not the patient died. But this is not the only information, the only data set you will need to derive this variable. That's one of the data set. And then again, to understand how SCTM, or what SCTM contains, you will look at the defined XML of the SCTM, and so on and so on. And essentially, and then it may also open the annotated CRF to see visually your variables, and that's what is missing today, and what may be not missing in a decade probably. You will also need a link. You will link to the basically to the origin of the data, so the data collected at the hospital. This is where this is working, and maybe also a link to the study design. So also the study design for the protocol information may be also in a format of a data set. So that's in summary is summarizing the concept of traceability. So in essence, you need to be able to trace back from the output to the origin. And the other way around. You start from the SRF, you go to the SCTM, to the dataset, to the define, and you go up to the. So you need to be able to trace back, right? That's not a new concept. Actually, everything we do in our day-to-day work has to be traceable, right? That's GCP. It's not just CD saying this. So how to achieve traceability in Adam? So let me see. 36. Okay. So as I said at the beginning, Adam has to be derived from SCTM. No need to copy all source dataset, all source records from the dataset. So if you are creating, for example, your analysis of your laboratory, it's only focusing on chemistry and hematology. You're not required to, if you don't have any analysis on urinalysis parameter, there is no need to copy urinalysis records into your ADLB dataset. And similarly for questionnaire, if you're only analyzing one questionnaire among the ones you collected, just copy the records of that specific questionnaire. Okay, that's something we already covered, right? The last point, bullet points. And then, in order to be traceable back, you can be traceable back to the data. It's not mentioned here, but in that case, we say you are traceable back from the data, so it's data point traceable, and you need to include variable from SCTM. For example, the sec variable in SCTM is numbering it's assigning a unique number to all records in the SCTM. So your analysis data set to be well traceable. It's recommended to keep this variable in Adam so that you know from which exact record your Adam record is coming from. And when your Adam dataset is coming from, it's generated from more than one dataset, in that case you cannot copy the seek variable. Instead of copying the seek variable, you make use of three variables that basically says, okay, this record is coming from this dataset, in this case SS, from this record, so the third record of the subject in this SS dataset, and this is the variable I'm using to build my analysis value in Adam. Okay, that's needed when you have more than one SCTM as a source of your Adam. Okay, otherwise you can simply use for example, in an ADIE, you can simply use ASEC. And then you keep SCTM variables for traceability whenever you make some, for example, some imputation. Like here in SCTM, you may have a situation like this where the labs was not able to quantify the exact value of the parameters, so you may see very often things like this, below something, and you don't make any assumption in SCTM on what is it below 6, but then in other you need to treat this number as a number, and you make some assumption, like for example you make some derivation, you say that, okay, below 6 means a little bit below 6, so it's 5.9999 something. But you don't do that in the original variable, as I said at the beginning. You do this in the analysis variable, and to be traceable, you keep this variable to show to the reviewer that you make this kind of assumption. Okay. Of course, then in the metadata and the defined XML, you have to describe this as well. Traceability is also achieved by using a specific set of variables, standard in Adam, called flags. So if your Adam data set, you have several records, but not all records are used for a specific analysis, but they are still in the Adam, you need to flag them or unflag them. So you need to say with the variable, okay, these records are not used for this analysis, for this table. Okay, this is very important. Again, to be trustable, to be transparent with the reviewer. So the reviewer is, can see from the data which record has been not used. Okay. And then when you have a complex derivation, you can split your derivation in several data sets. So the concept of intermediate data set that I'm not discussing in details here, but you have something in the backup slide. And then when you validate your Adam with Pineco 21, just remember that there are some checks that verify traceability back to SCTM. And this is, for example, for ADSL. The checks verify that all records in ADSL are present in SCTM DM. And similarly for AE, there is a check verifying that all adverse events that were present in SCTM are also present in ADA. So when you validate your ADA dataset, remember to include also these 3 datasets. Okay, then there are other examples in the backup slide about how to impute, for example, missing or partial date and time. Okay, I'm not covering this, but there are specific rules. Okay. That's what I mentioned before, the use of analysis flag. In this specific analysis, it was a repeated analysis. You can see here, oh yes. Okay, there was, so yeah, I did this analysis, so I should remember this. So there was a repeated time point analysis, and it was about daily pain intensity the patient was having after receiving some treatment, and the pain intensity was collected every day, right, with a score. And for the baseline, we needed to basically take the average of the 7 days prior to the start of the treatment. So you can see here in the dataset all the 7 days. Actually, here there is a missing observation because probably day -1 was skipped by the patient. And then you can see here, okay, this is something will be introduced later on, that we create an additional record containing the average. And also here you can see that we use a flag. So this record was not used to build the average, because the other rules was that you should consider the 7 days prior to the treatment, but you should exclude the days where the patient was still receiving other treatments. So there was a washout period, right? So in this date, the patient was still in the washout period. So this number was not used in the average. And this was described, of course, in the defined XML, but also in the data, the record was not flagged, meaning that the record was not used to derive this average, okay? Then the concept of being analysis ready. This is one of the concepts that often it's misunderstood, and it's often the source of misunderstanding and debate and fight with some sponsor. Okay, they have their understanding of what should be considered analysis ready. So again, these are definitions from the Adam guidance, and essentially. An analysis data set is considered analysis ready when the analysis data set contains all the information that are needed for the output production with minimal programming. It means that all derivation in few words, means that all the records you need for the tables, all the derivation, all the derived variables that you need for the tables are in the other data set. Okay? And you also, to make analysis ready, you also need additional variables that may come from a DSL that for making selection of records. So if you need to create tables about, I don't know, beta sign, your beta sign data set, let's make a better example. If you have an analysis data set supporting your primary efficacy endpoint, and your primary efficacy endpoint is analyzed with the different study population, ITT, efficacy population, therapeutic population. So your analysis data set should have these three study population indicators. Okay? So that in your output program you will not need to merge your primary efficacy endpoint analysis data set with ADSL to get the population indicator. You already have everything you need in your data set. Okay? So ideally it's one block away. Again, that's the source of misunderstanding. And there is on purpose redundancy. Actually, redundancy, it's in everything we do, there is a redundancy. So redundancy means that if you have variables in one atom, it's very redundant. Okay, while SNTM is not. So it means that you may have a variable created in one data set that is then replicated in several data sets, right? The example of the study population indicators. We don't have this in SNTM. That's why SNTM is not analysis ready. Okay. Just to make an example on the what does it mean one block away. So because very often people think, okay, in my output program I can only use my SAS procedure, and that's it. I cannot make any sets. I cannot make any work data set because everything should be in my Adam data set. My Adam data set should be one block away. Okay, that's a source of misunderstanding. So, for example, in this statistical program, there are two procedures, right? And so it's not one block away; it's 2 block away. Okay, and but still analysis. And for this table, these two programs, these two calls of the GLI procedure, they are needed because in the output you want to create, there are two different sections, and for two different sections you need two separate calls of the GLM. And then of course you need to extract from the GLM using some ODS statement the results you need to combine to make a very nice table, right? So this is still analysis ready, right? Okay, the fact that you have called two procedure, the fact that you have rearranged your result to make the table nice doesn't mean that your Adam was not analysis ready. Okay. Why? This is instead not analysis ready because, as I said, the Adam dataset should have all the derivation you need to support your tables. So creating in the output program the age in group, because in your table you need to report the age in group, in addition to the usual way. That's something you should do in your Adam dataset. So creating this age GR1 dataset should be done in Adam, and not in your output program, because somehow you are hiding something here, some information here. So the reviewer will need to open the dataset to understand how you derive age in category. While instead, if it was derived in Adam, this was not somehow hidden. So the reviewer needs to open the dataset to understand what you did. Okay, that's a very simple example. You may have very more complex derivation. There are additional requirements, and coming from the FDA Study Data Technical Format Guide. Essentially, they are repeating what is in the implementation guidance. Yeah, they're giving some advice. So the reviewer, the FDA recommends to keep all variables. So if you are deriving a new variables, and for deriving these new variables, you are using several source variables. Keep this source variable in Adam. Okay. Or they're giving other recommendation on how to label the Adam dataset. Or what is the other one? Okay, yeah, that's your your ADAM data set, again, the last point is it's again about being analysis ready. So your ADAM data set should contain all possible subject characteristics or covariates that may be used for making a plan analysis, but also unplanned analysis. So the reviewer wants to have some kind of analysis data set ready for further more detailed specific analysis on specific subgroups. Oh yeah, and that's more or less what's in the previous slide. Intermediate data set mentioned before. I will skip this. It's just a recommendation where you have something very complex to, instead of creating one analysis data set, split your derivation in several steps, and for each step create an analysis data set. There is an example in the backup slide. I can also provide more examples from a presentation I did with Teresa Curto, a colleague in the US, at one conference. Okay. Then, okay, good and bad ADAM. Just to clarify some misunderstanding. In the backup slide, there's also kind of joke. I was making another training showing a bad implementation of ADAM, and then the people attending the course had to identify the mistake. So if you want, this is in the backup slide. Okay. Okay. One of the and unfortunately this is still a gap in the standard. But that's a recurrent mistake I can see also from the sponsor. So people using the parcat variable to qualify the parameters. So this is an example for overall response in oncology, where you can have an overall response assessed by the investigator and the reviewer. And so instead of creating, people want to, instead of creating one parameter for the investigator and one parameter for the reviewer, people that create just one parameter, because in the end it's the same concept, best overall response, and they have the parcat. This is not acceptable from the standard point of view. So you need a parameter for each, one parameter for the investigator, one parameter for the reviewer. Okay, this is not really annoying in this case, but it can be very annoying when you have several parameters. For example, I have done on a ophthalmology study where they were measuring several information on both eyes, so like 50 parameters for both eyes, making 100 parameters. So I had to basically create 100 parameters instead of 50 parameters with a variable saying whether it was left or right eyes. They were thinking to introduce a variable called parkour, but apparently with the new guidance that is coming out in a few weeks, some kind of committee in the top of CDISC refused this variable. Don't ask me why. Okay, that's very complex. I'm not going through all this. So the implementation guidance, I have this is specific for the BDS structure. They have basically they define 6 rules showing 6 different scenarios, and based on these different 6 scenarios, the rule that basically the ADAM says whether you are allowed to create a new variables or whether you have to create a new record. So except one rule 1, all the other rules require creation of a new record. For example, just see one. The third one, we saw it before. A function of one row or more rows within the same parameter for the purpose of creating an analysis time point should be added as a new row for the same parameter. Okay, it's not. Before you said you saw the calculation of the average, right? The average of the 7 days prior to treatment. Okay, it's not the average. Is not really a new parameter. It's like deriving a fake. Actually, we derived a kind of fake time point, which was the fake baseline, right? Because the baseline was defined as the measurement of the previous 7 days. So somehow we derived the time point, actually. We derived the baseline time point. So the rule here is that when you do that, when you use within the same parameters, in that case was the pain parameters, when you use several records with the purpose of creating a new analysis time point, you need to create a new row for the same parameter. Okay. if after the training you go back to the previous example, this should be clear. So I'm not going through all these rules, but these are rules, when you implement Adam, these are rules that you have to keep in mind. And not going through this, but this is coming from the CD's Adam training, and they basically visually explain all the 6 rules in the previous slide, and they make an example on the use of some specific variable, in particular the D-type variable that you saw before when I make the example of the mean. The D-type variable is used to indicate if the record is derived or it's coming from the source. Okay, in the example there, the third example, log F means that they imputed a missing time point by using the last observation carry forward method. Okay, I'm not going to cover this. And again, this is related to, very similar to the example we made before. So if you have to create a post baseline, the minimum observation across many observations, the recommendation is again to derive a new record. This is one example just to say you have two analysis variables, eval and eval-c. So eval is for numeric results, eval-c is for character results. And very often you need, it's mandatory to have either eval or eval-c. But you're not obliged to have both. So if your result is of a numeric nature, use eval. If your result is of a character nature, use eval-c. But do not use both. Okay? This is one of the exceptions. It's when you have whatever questionnaire, quality of life questionnaire, where the result is a numeric, or better, the result is character in a kind of incremental severity, from very bad, bad, and good. And again, because you want to analyze these in both ways, as a categorical way, you want to use the very bad, bad, and good in your table, but then you also want to analyze this as a numeric value, so you want to make the average. Then that's the situation in which you can have both. Okay. Otherwise, in most of the case, your dataset will not have both variables. Or if your dataset have both, it's because your dataset have parameters of both numeric and character nature. So if the parameter is of numeric nature, then eval will be filled, and eval-c very likely will be null, and the other way around. If your parameter is of character nature, eval-c will be filled, and eval, if present, will be null. Okay. That's another complex example I will skip. It's very similar to the example I made at the beginning when I showed a way of using the BDS dataset to summarize the subject adverse event experience. Here it's the same for exposure. You need to combine several records together to derive information like a number of administration, that's specific for oncology, relative dose intensity, treatment duration, and instead of making this derivation in the output program, you can create another dataset with one record per patient per summary information that then you will use in your table. Okay, so each summary information is a parameter, and there is more, of course. Like for example, when it's very often people misunderstand the use of flags. So use flags when flags should be not used to categorize variables. There are specific variables to categorize variables. Like if you have to categorize the value of eval or eval-c, there is a standard variable called eval-cat. Similarly for base. To categorize a group variable in ADSL and NDIE, you can create a variable whatever you like, but just put a prefix called GR. In BDS, you can use, so if you have to categorize eval, you use eval-cat. If you have to make more complex classification, there are a set of variables called crit. There are more in the backup slide. I recommend to read this very nice paper presented at Pharmasug, which somehow drive the programmers in the choice of flags, of criteria, of category, depending on the need of the analysis. And then I think I said this already, but just include standard variable in your Adam dataset only if needed. So if you don't have any analysis by period, there's no need to create any period variable. But the more variable you add, the more you have to maintain the dataset, the more you have to explain, the more you have to provide the file XML. So do not put in your dataset information that are not needed in the analysis. And respect the implementation guidance. This seems something, as the French say, ça va sans dire, you don't have to tell me. But actually, we saw one test submission made by the sponsor where the dataset were containing some variable ending with DT. And when it's ending with DT, it means it's a numeric date variable, but the sponsor put some character variable, so some characters. So you have to respect you have to have respect of the standard, okay? Okay, like SDTM, also Adam has its own terminology. It's very limited, but again, if your variables has a terminology, follow it. And you cannot see here, but there is the path of our Citrix server where the Adam terminology is stored. So there is new guidance coming, the 1.2, which has not that much. It's more about the new guidance clarify more concept rather than introducing new concept. And as I said at the beginning, there will be more guidance, especially this one. I hope it will come soon so that we can see if there is a standard way for integrating data, for pulling data. Okay. What else? Mentioned at the beginning, if you're familiar with the fine XML, so the fine XML is the standard to basically describe metadata, so describe variables, attributes, describe algorithms you use in your data set. It's the same for SDTM. Adam has just one difference from the SDTM. It has one additional metadata called analysis result metadata, or ARM, which define another set of metadata to basically describe your output. So the data set you selected, the data set you use for the output, the variable you use for the output, and even the statistical model you use. So you can cut and paste key information from the SAP. You can also specify the exact statistical procedure you use, so that the reviewer can see exactly which specific model, which specific option you use. In this case, it's propagate reg for survival analysis. Okay. So this is an additional, a kind of define XML add-on specific for Adam. We haven't done that many ARM so far, but just because it's not yet mandatory by the FDA. We have one tool called Pinnacle Enterprise where you can make ARM. Myself, I did once. It's just for your knowledge. So if the sponsor asks for this, do not, how do you say in English? Fall down from the seat. That's what we say in Italian. Just be prepared to answer. Yes, we can do it. Okay. Add-on validation. As you know, every time a standard is how many slides I have? I don't know. I think 2 or 3 more. As you know, every add-on standard comes with something called validation rules or conformance rules, which basically, if implemented, if programmed, they give an idea whether or not your data set, SDTM or Adam, is conformant to the guidance, to the rules specifying the guidance. So as of today, so our standard tool for validating the dataset is Pinnacle 21 community version. Unfortunately, for the implementation guidance 1.1, which is the version we can use because the version that FDA accepts, the conformance check has been not delivered yet. So the Pinnacle, the tool we are using is basically able to only check other dataset programmed with 1.0, with implementation guidance 1.0. As such, there are some kind of false negative. So if you validate a dataset, an Adam dataset created with the implementation guidance 1.1, you may get some errors or warnings. These are false negative because the tools is somehow not updated. but you can skip this false negative and describe any warning and errors in your reviewer guide. Of course, you need to have a kind of experience to understand, okay, this is a warning or errors Pinnacle is giving to me because the specific check for the implementation guidance 1.1 is not implemented yet. Okay. Other topics that are in part covered in the backup slide. So there is a electronic common technical document. There is a specific folder where ADAM dataset should be stored. ADAM programs and key output programs, so like primary efficacy outputs, are required in the submission package by FDA and PMDA. So that's to say, try to write nice programs that everyone, not just the reviewer, but also myself or Magali, but if she has to take over a program from someone else, please write nice program, well documented, because these may be part of the submission. Okay. And also, when you create your defined XML, make sure your derivations are clearly defined. Do not just simply cut and paste the source code. Okay. And then nice review guide can be a topic for another training. This is another required document when you submit data set in a standard format. And this is what's more in the backup slide. Some suggested reading, and I think we are at the end. So I used 10-15 minutes more than expected, but I stopped recording.